revise the chapter light. Light, my friend, has dual nature. But in refraction, it doesn't go back. Whenever we study physics especially, we are going to see so many laws. Laws are basically how things work. So if the outside surface is reflecting, that is called convex mirror. Hello everyone, welcome to Diksha Vedantu. I'm your teacher Aditi, and in this video we are going to quickly revise the chapter light. Ma'am, why are we putting these quickly 30-minute revision sessions at this point of time? So see, it is very important, as we tell, whatever you study in the class, whatever you study in the coaching, go revise that at home, right? So this is like your monthly revision. We have done with the chapter light. We read it completely line by line, NCERT understood, got the one shot, and that one shot was really long, right? So just to concise that chapter in a smaller manner, just to revise it quickly so that it gets engraved in your soul is the sole purpose of this video. Okay, so let us start with the very basic, very first chapter of your class 10th physics for the session 2027, the chapter light. We are going to study about reflection and refraction in this chapter. Okay, so let's start with what exactly light is. Okay, let me tell you. When you close your eyes, what do you see? You see nothing, and you see something black, right? That is the absence of light. Why am I able to see this beautiful sky out there, this beautiful sunrise, sunset? That is because of light. So what exactly is light? Light is nothing but a form of energy that enables me, that enables all of us to see this beautiful world around us. Now let's dive deeper into a bit of scientific part of it, right? Now, as we know, some said, Newton said light is a particle, but Huygens sir said, no, Newton, you are wrong. Light is actually a wave. So what exactly it is? Light, my friend, has dual nature. It acts both as a particle and wave nature. It acts as a particle and something like a wave. It acts as a particle and as well as a wave. Now, we are going to study two phenomena in this chapter. What is that? Reflection and refraction. The bouncing back of light. Bouncing back of light is called reflection. This is a board. A light came, there is a huge light here. Okay, can you see me in my lenses? There is a huge light here. It came, strike this surface, went directly into your eyes. And that is how you see light. Bouncing back of light when it strikes a surface. Bouncing back of light. So this is my incident ray, and then it reflects back, and that, my friend, is my reflected ray. This is my incident ray, right? And this is my reflected ray. Okay. Then the next part we have, that is my refraction of light. Reflection of light, refraction of light. What is refraction of light? Here we had a surface and it came and it went back. But in refraction, it doesn't go back. It doesn't bounces back. It travels to the another medium. Let's say this medium is air, and below this line, this medium is water. So when light enters from air into the water, it gets refracted. Let's study what refraction is. Bending of light. Bending of light when it passes from one medium to the another, and both of them should have different density. What is density? Just the presence of molecules. Let's say in water, the molecules there are 3 molecules. 1, 2, 3, 4. 4 molecules in this particular space. But in the same particular space, in air, there will be only 2 molecules. So density of air is less than density of water. So this is reflection is bouncing back of light when it strikes a surface. Refraction is bending of light when it goes from one medium to another. Okay, then we have laws of reflection. Whenever we study science, whenever we study physics especially, we are going to see so many laws. Laws are basically how things work, okay, and how things work repeatedly in every manner, in anywhere on earth, in anywhere in space, universe. Those laws remain the same. So in reflection, we have 2 laws. First is angle of incidence is equal to angle of reflection. Now what does that mean? Say this light ray came and it strikes a surface, it struck this surface and it went back. Okay, let's see the previous diagram. Here, can you see the incident ray? It struck the surface and went back. So these 2 angles, incident angle, This is called incident angle. How it becomes? This, my friend, is normal. Okay, so this is incident ray, normal and reflected ray. If, however, you want complete explanation of all this, what is normal, what is incident ray, then I will ask them to paste a link in the description of the one shot of the chapter light that I've created, so you can go watch that as well. Okay, now this is incident ray, normal, refracted ray. The angle that incident ray makes with normal is called incident angle. The angle that reflected ray makes with incident is called reflection angle. Okay, now this I and R are always equal. That is, my friend, my first law. The angle of incidence, this is normal. The angle of incidence is always equal to the angle of reflection. Then next we have the incident ray, the normal and the reflected ray at the point of incidence. At the point of incidence, all lies in the same plane. They all lie in the same plane. Then these are the two laws of reflection that we have to get engraved in us all. They will be asked in the paper as well. This is very important. Okay, then next we have laws of refraction. Just like reflection, we have laws of refraction as well. Now refraction says the first law is same, but here instead of bouncing back, the ray just passes. This is normal, it bends. Now there was two more things to remember, right? From rarer to denser, when the light goes from rarer to denser, it bends towards the normal. When light goes from denser to rarer, it bends away from the normal. Done? Okay, now two laws of refraction were, this is now my incident angle and this is now my refracted angle, and this is, let's say, a rarer medium, this is denser medium. So as it goes from rarer to denser, it bends towards the normal. What are the two laws? First is same, the incident ray, the normal, the refracted ray at the point of incidence, at the point of incidence of two pair of medias, the interface point. See, this is called the interface. This, my friend, is called the interface. Interface is the point, that surface where the mediums are differed. Here this is air, here this is water. So this surface is called interface. So the incident ray, the refracted ray and the normal to the interface of the two transparent media, water and air, are the transparent media at the point of incidence. At the point of incidence, all lie in the same plane. Okay, this is the first law, almost similar to reflection. Now we have a very important law, that is, in case of refraction is called Snell's law. In case of reflection, it was angle of incidence. Angle of incidence is equal to angle of reflection. That was that. But in case of refraction, what is this? It's called Snell's law. What is called Snell's law? That means sine of I divided by sine of R. Sine of this incident angle. Here, if angle I is 30 degree, then reflected angle was also 30 degree. Let me just change the pen, I think. Yeah, if angle I is 30 degree, then reflected angle was also 30 degree. But in here, the specific values are not same. Let's say this is 30 degree. So, and this is also, let's say, 20 degree. So, 30 and 20 are not same, right? But sine of 30, what? Sine of 30 divided by sine of 20 will always be constant. This is the second law of my refraction. Done? Understood? Okay. Let's move on to the next part. Now we are moving on to the part we have optical instruments. We have two kind of optical instruments. One is mirror and second is lenses. Both are spherical, so spherical mirror, spherical lenses. Now we have two kind of spherical mirrors. Very good. Write down in the comment section right now. We have two kinds of mirrors, concave mirror, convex mirror. Now I have a question for you. How do you distinguish between two mirrors? You have concave, you have convex. You have studied about that. The first chapter is done. How do you understand, how do you remember in your mind that this is concave mirror, this is convex mirror? Let us know all the tricks in the comment section so that other toppers can pick that up from you. Okay? So first is concave mirror and the second, my friend, is convex mirror. How do I remember this? See, this is a concave mirror. So this looks like a concave, this is like a cave. The cave, gufa, right? So this is a cave. So when the light is entering into the cave, When the light is entering into the cave and then it reflects back. Then it reflects back, which, yeah, when the light is entering into the cave and it reflects back, that is called concave. But here, on the other hand, we also have another mirror, that is convex mirror. Also a cave, but light is not going into the cave. The light is now on the other side of the cave. This is cave, okay? Inside the cave, we have a person or a dog, whatever this is. I don't think this is a dog. Whatever this is, inside the cave, we have a tiger. But you are on the outside, you are safe. So outside of the cave, outside surface is reflecting, that is called convex mirror. So if the outside surface is reflecting, that is called convex mirror. If the inside surface is reflecting, that is called concave mirror. Done? Understood? Okay, then we move on to the image formation by concave mirror. This is very, very important. This is very, I know students find it very tough. Okay, let's just understand it. Okay, there are 6 cases. Remember, how do you have to remember? As soon as you think of concave mirror, then there are 6 cases. 5 cases are normal, 6th one is exceptional. That is it. Now let's start with the first case. First case, the object is at infinity. The object is at infinity. And when the object is at infinity, the image is formed at focus. Done. First case, loud and clear. And I know for these 5 cases, all these 5 cases, the image formed is real and inverted. The image formed is always real and inverted for the first 5 cases. So this is real and inverted. Done. Let me just go to some other software for you guys so that I can make you understand better. Okay? Yeah, here. Now, nope. Wait. Yeah. So, image formation by concave mirror. The first is the object is at infinity. The image is where? The image is at focus. Done. Now, in fifth, for all the 5 cases, the image is real and inverted. RNI means real and inverted. We have studied in one shot. If you haven't, go watch that one shot. I have explained it in complete detail in that. Okay? Now in the second case, ma'am, in the second case, we bring the object closer to the mirror. Now it was at infinity, but now it is not at C, at F, it is beyond C. We know what F and C is, right? It is beyond C. Now when it is beyond C, one ray will go parallel, will pass through focus. The another ray will go through center of curvature, reflects back and passes from the center of curvature again. Okay, so the image will be formed between C and F. The image will be formed between C and F when the object is beyond C. Done. Third case, we brought the object more closer to the mirror. Now the object is at C. Ma'am, at C, we are very clear. One ray goes parallel, passes through focus, another ray goes through center of curvature, comes back, and the image is exactly at center of curvature, exactly of the same size. Also, the image in all these cases is still real and inverted. Real and inverted, because we know for the first 5 cases, the image is real and inverted. Okay? Now, also one more thing you have to remember. In the first case, see, the object is at F. So it is point size. So it will start increasing its size. When the object is beyond C, when we brought it closer to the mirror, its size will increase. Definitely makes sense. When we brought the object more closer to the mirror, the size becomes equal to the object. The size of image becomes equal to the object. Now, if we brought the object more closer to the mirror, that is between C and F, the size will increase even further. And here, the image will be larger than the object. Right? The image will be larger than the object. Now again, one ray goes parallel, passes through focus, another ray goes through focus and goes through parallel. These are also one more trick, right? The one ray goes through focus and gets parallel back. Done. Then, in this case, the image will be formed beyond C. See, at first, the image was at infinity. The object was at infinity. Image is at focus. We brought the object closer. So now the object is beyond C. The image will be between C and F. The object is at C. The image is at C. We brought the object more closer. Now the object is between C and F, but the image got farther from the mirror. So image is at beyond C. As the object is coming closer, the image is going away. The object is coming closer, image is going away. Done? Understood? Then we have the fifth case, last normal case. Fifth case, now the object is at focus. At focus. Now the image will be either it won't be formed or it will be at infinity. You can write at infinity. According to new NCERT, let's just write not formed. Okay, so in this the image will not formed. If they are still asking the size, let's write it extremely large. Okay, now coming to the sixth case, the exceptional one. Remember, till fifth case the image is real and inverted. It gets larger as we move towards the mirror, right? And yeah, that's it. Okay, so sixth case we have the object is between focus and pole of the mirror. We brought the object more closer. The object is between focus and pole of the mirror. One ray will go parallel, comes back. Now the ray still goes through center of curvature, but we saw these rows are going away. They will not meet. So we extend them backwards and they meet at a point. And this, my friend, is not a real inverted image. This is a virtual and erect image. And it will be formed behind the mirror. Then let's move on to the second, that is your convex mirror. In convex mirror, we just have two cases. First, the object is at any point between infinity and pole. Any point between infinity and pole. Let's just take the first, that is at infinity. So all the rays go parallel, they meet at focus. But now we know this is a diverging mirror. This is a diverging mirror. Concave mirror was converging mirror. So all the rays were coming towards each other. This is a diverging mirror. All the rays are going away from each other. So we extend them backwards and we see this is the focus of the convex mirror. So it meet at the focus, and so the object is at infinity. The image will be again at focus. Then next we have at any point. Now we don't do that at beyond C, at F. No. Any point between infinity and pole, the image will be formed between pole and this will be your focus. So it will be between pole and focus. Not the focus will somewhere be here. Okay. So this image is formed. This image is formed between pole and focus, and it will be small. And for convex mirror, in both cases, the image will be virtual and erect, and it will be of small size. How to remember this? Let's just revise it once again. What is the revision? Okay, image formation by concave mirror we get real image as well as virtual image. For the sixth case, we have virtual image, right? So it is real as well as virtual. For first 5 cases, we get real image. For sixth case, we get virtual image. Then for it is of all sizes. It is of point size, it is of smaller, same size, larger, extremely large, right? So it is of all sizes. Then it is inverted as well as erect. First 5 cases, the images are inverted. Sixth case, the image was erect. Then moving on to convex mirror. Again, here it was real as well as inverted, here as well as virtual. But in convex mirror, always just the virtual image is formed. So always virtual, always diminished, always a small image is formed, and always erect. So for convex mirror, virtual, erect and diminished. That's it. That's the only thing you have to remember. For concave mirror on the other hand, for first 5 cases, it will be real inverted, small, big, all the sizes. But for sixth case, it will be virtual and erect, and it will be larger in size. Okay, let's move on to lenses now. Before that, we have to study about refraction. So we have studied about what is refraction, right? We saw laws of refraction, bending of light. Now, this is an application of refraction. This is air, this is water, and then this is again air. You have seen glass lab. Maybe a lot of you schools have gone into the labs. So you must have seen the glass lab. There is an experiment in 10th class also. So what you will do, you will take a glass lab. What is a glass lab? It's just a very thick glass. Okay, just a small rectangle, very thick glass. I'll show you a picture of that also. Now, what will happen from the above, the light will go in, then it will enter into the water, then it will come out in the air. But let's see how exactly it will do that. Okay, now this is the light ray from air. It is going from air into the water, that is rarer to denser, right? And this is again rarer. So light ray goes in at the point it is get incident. Now it will not go straight, right? We know refraction. It will bend towards the normal. It will bend towards the normal, right? So instead of going straight, it bent towards the normal. Now again on the other hand, it will come out as well, right? Because again here is also glass. So now it is going from denser to rarer. So rarer to denser, it bends towards the normal. Denser to rarer, it will go away from the normal. So this will go away from the normal. Instead of going straight, it went away from the normal. Understood? Very, very easy. Two things you will have to remember. Here the angle of incidence will be equal to the angle of emergence. This is called emergent ray, that is emerging out of the glass slab. So incident ray, refracted ray, emergent ray. Done. So incident ray and emergent ray. Incident ray and emergent ray will be parallel to each other. If you extend it, these two rays will be parallel to each other. And the shortest distance between them is called lateral displacement. Lateral displacement. Lateral displacement is, instead of going straight like this ray just shifted here. It didn't turn like this, it didn't turn like that. It just got up and shifted here. Okay? Then that is called lateral displacement. Angle I is equal to angle E. Incident ray is parallel to emergent ray. Then, okay, then move on to lenses. Now we have two types of lenses, concave lens, again convex lens. Now concave lens is again thinner in the middle. It is thinner in the middle but thicker at the edges. Thicker at the edges and thinner in the middle. Done. That's how you remember. This is my concave mirror. Convex mirror, however, is thick in the middle but thinner at the edges. Now in here, this is just opposite of the mirror. We know that by this much, right? Now, concave mirror was converging, so concave lens will be diverging. Concave mirror is converging, so concave lens will be diverging. Convex mirror was diverging, so concave lens will be converging. Convex mirror was diverging, convex lens will be converging. Then, understood? Okay, let's see again the image formation by convex lens. Now this will be similar to concave mirror. Concave mirror will be similar to convex lens. Convex mirror will be similar to concave lens. Okay? Now, image formation by convex lens, again 6 cases, 5 are same, 1 is different. Let's see the first. Again, the object is at infinity, the image will be at f2. The only difference is, now in this, the image will be formed on the other hand, because we know this is refraction, this is not reflection. Light is not going opposite, light is going to the opposite direction. It is not going back in the same direction. It is passing the lens and it is getting bent. Right? Hence refraction. So light is going from infinity and the image is at f2. The focus on the left hand side is called f1, right hand side is called f2. Okay? Then the object is beyond f2f1. Beyond 2f1, we call that center of curvature in mirror, but in lenses it will be 2f1. So the object is beyond 2f1, the image will be between f2 and f1, similar to concave mirror, second case. Then third case, at 2f1, that was at C. The object will again be at C. The object will, but here the object will not be on the same side. It will be on the different side because it is refraction. Right? Here what is happening? One ray is again going parallel. It is again going parallel. Ray parallel passes through focus. Okay, this is focus. Then one ray, remember, the ray went into the center of curvature and reflected back the same path. Here, similar, but this is called optical center of the lens. When the light ray goes from optical center, there is no refraction. It doesn't get bent towards or away from the normal. It goes straight. Okay, so one ray goes parallel, goes through focus. One ray goes parallel, goes through focus. Another ray goes through optical center, does not get deflected. Other ray goes through optical center, does not get deflected. Now this is at 2f1. The image will be at 2f2. Okay. Then we have the fourth case. The object is now more closer to the lens. Between 2f1 and f1, the image will be beyond 2f2. The image will be beyond 2f2. Understood? Then we have the fifth case. Now the object is at f1. The object is at f1. There in mirror, the image was formed at infinity or not formed. Same here. The image is at infinity or not formed, you can also write. In this also, your object size will increase in the same manner. Here it is point size. Here it is small, diminished, but increased a little bit. Here it is of same size because at f1. And then fourth case, the object is now larger. Now at infinity it is extremely large. 5 cases are done. In those 5 cases also, the image will be real and inverted. Then the image will be real and inverted. And then in the sixth case, just like the mirror, it is also an exceptional one. Sixth case, the object will be between f1 and optical center. Remember, you call it optical center in lenses and pole in mirror. So optical center f1, and one ray will go parallel, it will pass through focus, another ray goes through optical center, but they are going away. They won't meet. So we extend them backwards. And at a point where they meet, that, my friend, is your image. Now, in 5 cases, this is real and inverted. But in 6th case, this is virtual and erect. Virtual and erect. Done? Okay. Next, moving on to concave lens, which will be similar to convex mirror. Only have 2 cases. Now, in the first case, the object is at infinity. 2 rays will come parallel. And now, ma'am, these are diverging. This is the one very important thing you have to remember. These will not meet. They will go away. These will diverge. So, we extend them backwards, and this is where the focus at which they were meeting. This will be point sized. The image will be at focus, and in here the image will be again virtual and erect. Virtual and erect. Then, now similarly for the second case, anywhere between optical center and infinity, not pole at infinity, optical center and infinity. So I just placed my object anywhere at any point. One ray will go parallel, it will get diverged away, and we extend them backwards, it passes through focus. Another ray goes through optical center. So at the point where these 2 rays are meeting on the same side of the mirror, the image will be formed. Now this will also be virtual and erect, and it is small. Remember, in convex mirror it was also always small. Here in concave lens it is also always small. This is point object, this is smaller, right? So let's see now. Yeah, so convex lens, again just like concave mirror. Let me write it. Wait. This will make things very clear. Concave mirror. Now these two are converging. These two are converging. Done? Convex lens and concave mirror, both are converging mirrors. Both form real image for first 5 cases, and in the 6th case it forms virtual. It forms all sizes of images, point, object, smaller, larger. For first 5 cases the image is inverted. For 6th case the image is erect. Then moving on to concave lens, it is similar to convex mirror. It has 6 cases, it only has 2 cases. And this, my friend, will be your diverging lens or diverging mirror. Then it will always form virtual image, it will always form diminished image, it will always form erect image. Done? Understood now? Clear? Very clear? Okay, let's move on to, we have just small things left. The formulas that you will be using this chapter is a highly focused on numericals, and you will be asked lots of numericals, maybe some tricky, maybe some easy, but what will help you? These formulas. Now we have again 2 formulas, mirror formula, lens formula. For mirror formula, 1 by f, that is focal length, equals to 1 by u, where u is object distance, u is your object distance, v is your image distance. Okay, then 1 by f equals to 1 by u plus 1 by v. And magnification, this is called magnification. Magnification is what, my friend? It means how larger. We studied about the sizes, right? I'm again and again telling you smaller, larger. Why? Because on that basis questions will come in the examination. That is magnification. So what is the formula? Height of image divided by height of object. We saw image was different. Height of image divided by height of object equals to minus negative of image distance by object distance v by u. So 1 by f equals to 1 by v plus 1 by u. Magnification is height of image by height of object equals to minus v by u. Understood? Understood? Ma'am, you remember you are studying it from so many years. Yes, but you can also remember. It's not that tough. Okay? And when we do numericals, you will see how easy it is. Then for length formula, small changes. In here, instead of plus sign, we'll have minus. So 1 by f equals to, this is 1 by v. Okay, so this won't be it. 1 by f equals to 1 by v minus 1 by u. This is the clear formula. 1 by focal length equals to 1 by image distance minus 1 by object distance. Okay. Then we have magnification, height of image, height of object same. But in here it is plus v by u. For mirror it was minus v by u. In here it is plus v by u. Then one more thing very important is left, that is, oh, there are two more formulas, sorry for that. After that, one more important thing is, so refractive index we studied about. Refractive index is, we study refraction, bending of light. Refractive index tells us how much the light will bend. Maybe it will bend more in glass than in water. Maybe it will bend more in kerosene oil than in glass than in water, right? So how much that bending is, that is defined by refractive index. So that is n to 1, refractive index of medium 2 with respect to medium 1. That means the light is going from 1 to 2. Okay, this is n2, this is n1. This is medium 1, medium 2. When the light goes from medium 1 to medium 2, we write refractive index of 2 with respect to 1. Okay, that is n to 1. Now velocity will be inversely proportional. N2 by n1 equals to v1 by v2, and that will be equal to sine of I by sine of r, which is from the Snell's law. Right? Then we have one more formula, power of a lens. This is the lens I'm wearing. What is the power? You say, na, how much power is your lenses? So what is that? How is that calculated? This lens has a focal length. When you inverse that focal length, that is the power. But this should be in meter. This focal length should be in meters. So power is 1 by focal length. When focal length is in meters, then power will be in diopters. That is the SI unit of power. SI unit of power, and that is diopter. Done? Next, we just have a small thing, that is sign conventions. It's a big thing, but let's just say small thing. Okay. Now, above the principal axis, let's say these are my lenses. These are my mirrors. This is my mirror. And then this is my lens. This is my lens. Done? These are all. Now, these are principal axes. These are principal axes. So, above the principal axis, the height will be positive. Below the principal axis, the height will be negative. Then, left hand side of the mirror or lens. So, left hand side of the mirror or the lens, the distances will be negative. So, remember we placed object always on the left hand side. So, u is always negative. U is always negative. Right hand side on the mirror is positive, just like the normal XY axis. Left hand side it was negative, right hand side positive, above positive, below negative. That is same here. So right hand side positive, left hand side negative. Then we have focal length. This is very important. Concave. Wherever you hear concave, either concave lens, concave mirror, the focal length will always be negative for concave lens or concave mirror. For convex lens or convex mirror, focal length will always be positive. Focal length will always be positive. Done. And one more thing, for magnification. We studied magnification. If magnification has negative sign, it will be a real and inverted image. If magnification has positive sign, it will be virtual and erect image. Again, this was a revision video. If you guys want me to explain it in pura detail, then go watch the one shot. There will be a one shot of chapter light on the channel. Go watch that. That I explained it completely. Why negative, why real and inverted, why and all that stuff. All that answers you will get in the one shot. Okay, so you can go watch that. And some of the topics that you need to practice after this session. The rapid revision, it's almost over. So 30 minutes, 34 minutes, we are done with the whole chapter. Now, all the topics that you need to remember, then you need to practice. Glass lab, remember, I told you, so you have to practice the glass lab topic. Uses of spherical mirrors, where those mirrors are used. Spherical mirrors, concave mirror, convex mirror, where are those used? Then ray diagrams, you have to practice those, and numericals. Okay, so go watch that, and let me give you 1 or 2 questions. You have to tell me in the comment section down there. You have to tell me. This is the slide number 20. Slide number 20. Answer in the comments. Answer in comments. All the questions I've made you do in the revision. I've told you everything. Okay, let's just see. Okay, the magnification produced by a lens has negative value. I literally just told you, and these are all PYQs. Just to make sure that you take this seriously, these are all PYQs. Now, a lens has magnification has negative value. The image will be what? Will it be virtual or erect? Virtual and inverted, real and erect, real and inverted. Ma'am, for negative, we know the image will always be real and inverted. For magnification negative, image will always be real and inverted. Okay, next question. A student observed that the reflection of light from different types of spherical mirrors made the following statement. Okay, a concave mirror can form a magnified image and real image of an object. Concave mirror. Concave mirror. Okay, he's saying that it formed magnified and real, and that is true. We study concave mirror, the first case. For first 5 cases, it was forming real and inverted image, and it was also forming magnified image. So first statement is true. Convex mirror can only form a virtual image of an object. That is also true. We studied that for convex mirror, we remember the word always for convex mirror. So it always forms virtual and erect images. Virtual and erect images. So it is always form virtual and erect. The magnification produced by a concave mirror can be negative. Magnification is negative when what? When it forms real and inverted image. We just studied in here. So when it does the concave mirror, does my concave mirror produce real and inverted image? Yes, this is written. The concave mirror does produce real and inverted image. So this is also true. So for this, your answer will be C. C will be your answer. One more question. You have to give me the answer. Oh, this is a good question. So write the answer in the comment section. Answer in comments. And the slide number is 23, my friend. Slide number 23. Answer in the comments. For everyone who is watching, answer in the comment right now. This is a refractive index medium, refractive index question, and you just have to use this formula. Let me show you. This formula. By only using this formula, you will be able to answer that question. Okay, so that is it, my friend. This is your homework. Where it did? Yes. So this is your homework. Answer will be in the comments, and if the answer is not in comments, then you are responsible to write the answer in the comments. That is it for this video. The rapid revision of this chapter light is done. In 35-40 minutes, we have done the complete chapter, and we revised the complete chapter. If you still have any doubts, go watch the one shot. If you still have any doubts, we will be coming live as well. So go join our lives whenever we'll post the schedule. Don't worry. So join our lives, subscribe the channel. There will be a link in the description. Join that WhatsApp channel. You will get all the notifications there. Subscribe the channel, ring that bell, and I'll meet you in the next video. Bye.